So let's move forward with the next session by Pedro and Jasvir. One small note, during the opening session, I was saying that the final keynote, unfortunately, Adrian cannot be here. He was, for personal reasons, couldn't travel. But he just confirmed that he will deliver it, will do it remotely, and hopefully it will work okay. Without further ado, so Pedro and Jasvir, so you don't have to patch, which is great news. Thank you.
Okay. All right. Guess what, everyone? You don't have to patch.
That's it. We can go.
So today we're going to be talking about patching. My name is Jasvir. Most people call me Jazz. You should too. I've worked at a wide variety of worked for and with a large variety of small and large tech companies and startups, always in security all the time.
And I am Pedro Fortuna. I'm CTO and co-founder of JScrambler. I also co-lead the local OWASP Lisbon chapter. I've been working in security for many years. I do AppSec mostly, and sometimes I do talks. So Jazz, don't you think that some companies are like obsessed with patching, like that's the only thing they care about?
It does feel like that sometimes, doesn't it? As if the only thing that if we got right, if we were fully patched, life would be beautiful. In this talk, I want to talk a little bit about why patching is not the panacea, that it is hard to do, and that even when we are fully patched, not only is it hard to do, sometimes it is really difficult to roll out in time. And what else we can do, what other tools we can have in our tool chest to mitigate the risk of running unpatched software. But before I do that, if I can entice you to hit that QR code so that we can have a survey of how you feel about how we go about protecting software today, uninfluenced by the talk so far.
Well, that sounds a little bit pretentious, you know? But yeah, please help us out here.
Can take a couple of seconds.
Yeah. It's just one question. And I'm sure you're thinking like, oh, I probably would take all of them with me to a desert island, but those are not the rules of the game. So if you're going to a desert island, you are definitely taking patching with you. And there's one other thing, just one other thing.
Just one other thing?
That you need to take. So you have to make a hard choice. And by the end of the talk, we'll revisit the results with you, and we'll see what most of the audience thinks about this.
All right, on with the show. Patching is hard, right? We all agree. It takes a long time to create a patch, to test it, to make sure that it is functional, to make sure that it's performant, to go through quality assurance. And then after you've done all of this hard work, you still have to roll the patch out. And sometimes you're dependent on other teams. Sometimes you're dependent on vendors. And then you go through all of this negotiation. And then you finally roll the patch out into production. And even then, after you've done all of that hard work, sometimes the patch does not even fix the security bug that you have had. Have you had that situation? Oh, OK, only a couple of you. Maybe you guys work with much better teams than I do. I have some numbers to share with you. So on average, it takes 215 days for a patch to be rolled out. 215 days. It gets better if the patch is security critical. It only takes 181 days. A reduction of like almost nothing, right? 30 or 40 days. It still takes such a long time for patches to be rolled into production. It's interesting to note why the criticality of a patch does not seem to make a huge difference on how long a patch takes to land. A couple of nights ago, I was talking to Dinesh Cruz, and he pointed out something that I had not thought about, which was he uses how long it takes for a security patch to land as a bellwether for how good an engineering team is. And not all engineering teams are A teams. Sometimes we have to work with whoever we are working with, and not everybody is able to roll patches out quickly. So why do we patch? I think this is a question to start with. And like many of the talks here today, and actually over the last year, I turned to ChatGPT. I asked it, hey, can you write this talk for me? And even an AI said that the premise of this talk is too immoral for it to deliver. Too immoral even for an AI. But you can understand why, right? What ChatGPT is doing is giving the consensus view of the internet. And the consensus view of the internet is that patching is sacrosanct. I used to work with a CISO a little while ago, and he used to say that you have to do cost-benefit analysis of every security decision you take, but not patching, because patching is a must. And I think that that is a mistake that I would like to think, I would like for us to think a little bit harder about. So why do we patch? There's a concept in engineering that suggests that if your software running in production is unpatched, then it could be doing anything. Then you have no idea what is happening in production. That makes sense. But the converse of it is something that we sometimes implicitly come to believe too. It is that if your software is fully patched in production, then you know everything that is happening in production. And if I say it like this, and if you think about it, you obviously know that that cannot possibly be true, right? But it feels true. I'm sure all of you have a story like this. This is my story. Back when I worked at Google, I used to own the integration of a DOM parsing library called libxerxes. And Xerxes, one fine Monday, rolled out a security patch, but in the same update that they rolled out a security patch, they also removed functionality that my software was reliant on. And now I was stuck. Either I had to allow the vulnerable software I knew that was vulnerable, to continue to run in production while I raced along trying to re-implement the missing functionality, or I updated the software, I fixed the vulnerability, and then left my software broken again until I implemented the missing piece. Forced software upgrades, forced software patching, forces you to make these kinds of choices. In my particular case, a senior exec at Google emailed my manager to help me make time to implement the fix.
Yeah, we know how that ended.
Yeah. All right. Even our friends in compliance understand that patching can be difficult and takes time. The idea is that it takes software resources, it takes human resources in order to create and roll out a patch. And our resources are limited. It doesn't mean it just means that there will be times when software you know is vulnerable continues to be running in production whilst you are building or testing or rolling out a patch. Not because you're a bad security engineer, not because your organization is neglectful, but because software takes time. The question is, what can you do to mitigate the blast radius of continuing to run vulnerable software whilst you are doing this? This all seems pretty bleak, so what can we do about it? I think about patching as creating this beautiful basket of fruit. You have your apples, your mangoes, your bananas, but sometimes an apple can go bad and then lead to the entire basket of fruit spoiling. In this case, what would you do about it? Well, it turns out I don't even like apples. I don't know about you, it tastes kind of weird. So we don't even have to have them in the basket, right? This is the equivalent of attack surface reduction. What you can do is remove those parts of our software, those parts of our fruit basket that we don't need or want necessarily.
You can use the help of SBOM for that.
That's a good point. The other thing that can happen is fruit can spoil. Even the fruit that you like can spoil. And then they can result in contagion throughout the fruit basket. In this particular case, you can compartmentalize your fruit and separate them away. The fruit are still going to go bad, but because they are isolated, the badness is contained to one particular fruit or one particular compartment. Now, I'm going to give you concrete examples in software for what this looks like. As Pedro said, attack surface reduction. One of the mechanisms that we have is SBOM. We had the daddy of SBOM give us a keynote today. What does SBOM say? SBOM is software bill of materials. It says, if I understand the software that is going into my application, I can choose to remove software that I don't need or want. There's content security policy used by web applications. CSP allows you to say, I just want these particular libraries, just the mangoes and bananas for me and nothing else. There's no need for your application to be allowed to load up the entire internet. And then the third thing that we can do is a non-technology solution. We can have processes well, what we call CISO with a stick, where we come up with rules about what kinds of software we can choose to have, or policies about how code review occurs. In my particular case, back at Google, we had a policy of only one library, one version of a library in our third party at a time. The other technique that we have is isolation. Isolation just means separating out different parts of our application. Network segmentation is something I'm sure you all are familiar with, where not all nodes in your production system need to be able to talk to every other node in your production system, only the ones that they need to get their job done. Similarly, at the system level, we can make sure that we use things like seccomp and AppArmor to prevent arbitrary system calls from being callable, only the functions that an application needs in order to run. And finally, kind of close to our heart is virtualization. I don't want you to think about virtual machines. What virtualization does is it lifts up the application and then replaces each individual function or important functions with equivalent functions that do exactly the same thing, but in addition are able to do logging or prevent inputs or attenuate the outputs so that you control how much access these particular functions have. These things together mean that the extent of the blast radius of a vulnerability, of an unpatched piece of software, remains as contained as possible. I'm going to shoot through a couple of practical examples with concrete examples, starting with network isolation. I'm going to blaze through this because most of you are already kind of familiar with this. Ordinarily, you have an access that is occurring. It connects to a load balancer, and the load balancer in normal behavior either connects to a web server or an API server, and that web server connects to respective databases. Sounds good? Pretty good. If one day you come in and you see logs indicating that your load balancer is suddenly talking to your individual databases, you know you've probably been popped, right? Probably because you were running some unpatched software. Now you could, and you should patch that software, but if you have network rules, IP table rules that make sure that the load balancer is only able to talk to the nodes that it needs in order to get the job done, the work that an attacker needs to do to take advantage, to exploit the vulnerability, becomes a lot harder on them. Pedro?
The second example is a system-level isolation example, and for that, we picked ImageMagick, which is a widely used software to automate image edits, mostly used by websites, but because it's notoriously plagued by vulnerabilities. So we specifically picked one called ImageTragic. By the way, don't you think that security people come up with the best name puns
They really do.
I do think that. This is a command injection, but before that, let me explain how image magic works. It uses external programs called delegates to do its chores. It's basically a template. So you see this tiny example here. It's using curl to fetch any image stored in a HTTPS location. But what they forgot was the basic rule of web application security, that you should never use unsanitized user-provided inputs in your application. So they forgot about that, and it turns out like people can feed a command, and whatever the result of that command will be returned to the attacker. Okay, so this was a big one. So let's see that in action. Okay, so a little time for a demo. I'm showing the exact same example. So I'm just like listing the contents of one directory and just running convert. And as you see the listing. Oh, secret.txt. We might want to look inside. Tasty things. All right. Okay, it's just one line of text. We can probably find something more appealing, like
etc. something? Password?
etc password.
Ah,
yeah.
That's a good idea.
I'm sorry you have to watch me type very slowly. And here you are, okay? So this is, like most of you are pretty familiar with command injection, so this should be easy. All right, so obviously it was quickly patched, or it was, a fix was quickly issued. It's not the same thing. And apart from that, they recommended that you need to verify if the output looks like the image type that you are expecting. You should disable unnecessary delegations. Those like, you can think of those like plugins. And patch, all right? And what are these? These are stronger validation, attack surface reduction, and security updates. What else? What else can we do here? It turns out, like, even then, Elkentuff published this blog post advising people to use sandboxing. Now, he really meant seccomp. If you know seccomp, you have to recompile the software. So if you're using ImageMagick as a third-party dependency, you will probably not go that far of recompiling all of that. But there's another option on the table. It's called AppArmor. It's open source Linux control solution that basically takes out all of the capabilities made available to software, like the use of the network, access to files, other types of devices on the Linux system. And then you have to explicitly re-enable the things, and only the things that the application will actually need when running normally, not in exploitation mode, of course. So you have a small example here. If you can see it, it's enabling the use of the network and read and write permission to /home/foo for Firefox. So if you run that AppArmor profile, Firefox will actually not run properly because it needs more things. But it's a small enough example for you to follow. Okay? I'll give you a slightly more complicated one. So we rolled out this AppArmor profile to wrap ImageMagick around. I'm not going over like all of this. I'll just point out that it is indeed very restrictive in regards to what ImageMagick can access under the etc directory. And it actually needs a lot of stuff. I was surprised with that. So let's see that demo again, this time around with the AppArmor enabled. Okay, so we just run the program again. And as you can see, here down in the right, it was denied. So the ImageMagick asked for permission to the etc password, and it was denied. So it's not a surprise that we see permission denied over there. the exploitation was not possible due to the isolation provided by AppArmor. You should not try to write your own AppArmor profiles. They are difficult to get. You never know what the application really needs. It might not be showing today. It might show tomorrow. You might break software. So you should use industry-vetted AppArmor profiles. And a good place to start is go to the official repo on GitLab and start from there. Okay? They have AppArmor profiles for most things that people use these days. Okay? So there's no reason why you shouldn't wrap everything that you're running inside an AppArmor profile. Even if you're running those inside Docker containers or whatever, like it should still use AppArmor profiles if you can. The third example is an application isolation example. And for that, we built like this very small web app, which is vulnerable to an XSS. Basically, it takes an XSS vector using a get parameter, and then that gets reflected to the body of the page. So obviously, this is a pretty simple XSS. And to exploit it, we are using a multi-stage XSS payload. So the first stage is just this script element source. We're just adding and loading the second stage from baddomain.com/badscript.js. So this way, the attacker can change the injection, the second stage, at any given moment because they control the baddomain.com. And also, they limit the amount of characters that are being passed to the get parameter. So as you know, if the URL gets like too big, it kind of sticks out in the application logs. So it might be easier for people to discover the exploitation. The second stage is is this one. So essentially, it adds a listener to the form submission. So that page you saw, it's a payment page. So it's hooking into the onSubmit event of that form. It's iterating every form field, collecting whatever the user has typed into that form. Then it's pasting what it got to the console just to prove that it had successfully accessed the information. And last, it XHRs out information to an attacker-controlled dashboard. Now, I'll show you the attack playing out in a second, but before that, let me talk about how we are going to mitigate it. And for that, we're using Web Page Integrity, or WPI, which is a client-side sandboxing solution that we have developed. It allows application owners to control what scripts see and what they can do, much like AppArmor, but for the browser. Okay? It offers an expressive rules engine with which basically you can control a wide variety of behaviors like the ones that you see here. With it, you can do attack surface reduction because you can block out like the behaviors that are not needed or will not be needed by the application. And you can also set boundaries or isolation rules to basically prevent scripts from ever touching critical parts of your application. So we're going, for this one, we broke the demo in 3 small sets. The first one is really easy. What we're doing is we're rolling out this rule that it's not blocking anything right now. It's just like monitoring the network-triggered events related with script source elements and any type of networking event related with XHR. Okay? So let's see that. This is the XSS vector. I load the page with it, and now I need to fill the form. We're already seeing one thing being alerted to the WPI dashboard. This is the loading of the second stage script, which is already hit the page. We can see the domain. We can see like the signature of the get URL. And obviously, the injection is there, so, and we're not blocking anything. So I will be filling out the form, and then we'll see if the second stage was able to collect the data from the forms. And as you can see in the bottom, it was, which is not surprising. We were expecting this. The drop server, the attacker dashboard, has one new entry. Okay, so exfiltration was successful as well. And we have one new alert related with the exfiltration. So we can see the endpoint, we can see the method, XHR, and we can see also the script that triggered the action, the specific action that led to the exfiltration. All right, this one is done. So the next one, we're rolling out. All right, there's some delay between my screen and that screen. We're rolling out a second rule that will start blocking. We'll start blocking access to the form. Okay, so this is one of the code behaviors that we're seeing. We're not blocking the script from being loaded. What we're blocking is access to the form. Actually, what we're doing is only allowing access to the form to a very specific script that we're expecting to be dealing with the data being entered on that script, which is process form. Okay? Everything else will be blocked by default. Let's see how that works. So let's continue. Obviously, there's a boring part here, which I have to fill the form again. Maybe I can jump a little bit. Let's see. OK. I'm sure you appreciate. And as you can see, it wasn't able to capture the data on the form. Logically, we don't have a new entry on the drop server. And here on the dashboard, we have 5 new alerts. The first one is the addition of the second stage script, and 4 more, each per form field that was that the script tried to access but couldn't. So we have confirmation that it was blocked. Let's look inside one of these. You have information of what form, the form field, the specific type of information, and again, what was the script that initiated this particular action.
But the bad script is still loading, right?
Yeah, so that's the problem. That's what we are blocking here. So we'll specifically roll a new rule that will block any networking event caused by adding a script source element to the page, okay? So in this particular example, the page is so simple that no valid reason to do that exists. So we can just make the rule generic. We could make it more specific if we need to on a real case, but here it's not needed. We just kept it simple for you guys. I'm not. All right, so we need to fill in the form again. Let me do the same thing. All right. And let me pause here. So this is the page that comes after the form post of the payment form. We're sorry we didn't implement this page because this is a demo. Okay, don't judge, please.
Don't judge.
We're lazy people. But it's enough to show you what is going on. So we see the requests of the second stage, and we successfully block that request. All right, let's take a peek inside. It's very much like the previous examples. So you have some data on the event that was blocked, and yeah, so this is the whole.
So just so that I can summarize, what you were able to do is you were able to set up rules to alert when a bad thing was happening, to stop the exfiltration of data, and to eventually just block entirely the loading of those particular scripts on a vulnerable page whilst the software remained unpatched, presumably whilst the team would be racing to patch up that software. So this is a mitigation, this is a way of mitigating the effect of that unpatched software. And if we think about it, the same thing is true in the network case and in the AppArmor case as well, where what we're doing is, yes, the software remains vulnerable, but the blast radius of the software is reduced whilst the team is trying to patch the software. Cool.
Thank you for that, Jazz. And we are reaching the end of our talk. Before that, we promised you to show you the results of this survey. Let's see how many of you actually responded it. All right, so it seems like we have 6 responses. Oh, God, you might be lazier than we are. Well, I wasn't expecting that. Anyway, we have 6 responses. We have, all right, so the one that people picked the most was attack surface reduction. But let's start from the top. We have strong authentication, which obviously it's very important for security in general. But in regards to preventing exploitation, it will not add as much as other options that we see here. Then we have, in the bottom, vulnerability scans, SAST and DAST. Those are great to find vulnerabilities, but fully automated, like vulnerability scanning, they will not find like the hard bugs usually. So it's hard for fully automated to work that way. So you will not find all the bugs, okay? So you're still like putting out, oh, another one. Thank you for whoever like just responded to this. Thank you. So you're not catching everything. Then you have attack surface reduction, which is great. Like you can remove things that you are not using, and therefore any vulnerability existing in those parts will not affect you because they are not in production. This is great. But again, the parts that you do need might have vulnerabilities. They might be exploitable, I'm sure. So it just helps, but not much. And we believe that the one that we would take to a desert island,
if it was the only thing we could take.
If it was the only thing, apart from along with patching, would be the isolation mechanisms, which is getting traction. How much time do we have? We might be able to. Okay. Okay. Now it's a game. So for us, it would be those 2, and we could live happy ever after in the desert island. Just mangoes and bananas for us, you know. All right. You can still keep going. We need one more. All right. So while patching remains an important part of every cybersecurity security strategy, is not always the best option or the most practical. So there are alternatives like attack surface reduction and isolation that can complement patching. When patching will not save the day, they might. You can think of other alternatives too, I'm sure, but by now, hopefully, we have convinced you that these 2 can be highly effective. So by leveraging these alternatives and implementing them where appropriate, companies can have a better security posture and be better prepared against cybersecurity threats. Anything that you'd like to add here? Because these people are already like 40 minutes late to their patching.
It's funny to stand in front of a security conference and tell people you don't need to patch. I will tell you that. I hope that that's not the message that you take away from today's talk. We are pro-patching. I believe in patching. In fact, last night, Joshua, our keynote speaker, cornered me and said, I hope you make an exception for critical infrastructure. People die if software is unpatched, and that sort of hits you, right? But that's not what I'm saying. That's not what we are saying. We're saying that patching is hard, and that rolling it out is hard, and then there's gaps, there's periods of time whilst your software will be unpatched. Again, as I say, not because you're a bad security engineer, not because your organization is neglectful, but because rolling out software is difficult, particularly if lives are at stake, but actually for all of us. We need other tools in our toolbox to make sure that the blast radius of software remains contained. And we believe that attack surface reduction and isolation, as well as other kinds of processes, are a necessary part. Patching is great, but you do not need to patch immediately if you take all of these other steps in addition.
Thank you.
Any question? We have a few minutes.
Hello, and thank you for your talk. I'm sorry if I'm making any confusion here, but the web integrity that you are proposing, is it the same that Google is proposing and Mozilla is strongly against because it is a gatekeeper for the web, or it is a different mechanism? I couldn't understand if it is the same or if it is different.
Well, I can answer and then I'll throw it to you. So we're not proposing a specific mechanism for, let's say, isolation, okay? So we're proposing generically the use of isolation. Google or Firefox or Mozilla, they control the browser, so there's definitely some amount of isolation that they can bring and bake into the browser, and this guy actually knows a lot about that. But for instance, we talked about application level isolation. That could never come from Google or browser makers. No? We talked about seccomp. Could be delivered by the software maker. We talked about AppArmor. Probably DevSecOps is the best point. Like those are the guys that will decide to use that type of tool. So in general, our message is more generic than that. Not a particular solution that you should use, but to use isolation, to use attack surface reduction.
I think that that's exactly where I would go. We have specific examples of solutions in particular spaces, but there are other mechanisms with other parts of software where a similar kind of idea can be applied. Anytime we can make it so that what used to be a monolithic application is componentized, did I pronounce that right? Then you can make sure that contagion is limited.
But for the case of the web, it was web integrity from the Google, right?
Web page integrity.
The one that you showed for the forums.
So that's an application level isolation. So it needs to be shipped by the application owner, not by the browser. In fact, Google had a proposal that could be confused with this type of approach called web integrity.
Web integrity, yes.
And I think it just went away, so they dropped it. And there's some things. There are some things that the browser will be reluctant to do on the browser level because it might be promiscuous coming from the browser maker that you can do on the application level. And that's like the solution that we showcased is one example of that.
Anyone else? Okay, Pedro. Okay, Jess. Thank you so much.
Thank you.